Hello everyone, I'm Peter Shields from AirMet Scientific, and it's a pleasure to welcome you to today's webinar titled Breathe Easy, a comprehensive guide to respirator fit testing. This session aims to provide valuable insights for both newcomers and experienced professionals interested in enhancing their knowledge on respirator fit testing, which is vital for ensuring worker safety against hazardous exposures. We're fortunate to have three distinguished guest presenters from OHD with us today. Dr. Stephanie Lynch, OHD's Senior Technology and Research Manager, who's also the President of the International Society of Respiratory Protection. Luke Allen, the President of OHD, and Hunter Strickler, the Vice President of Business Development. Their expertise will enrich our discussion on this important topic. I'm particularly eager to learn about the innovative AeroFit technology they're going to discuss. So now let's hand it over to Stephanie, Luke, and Hunter for their presentation. Thanks.
Thank you, Peter. Thank you, AirMet, and for all the work that's gone in to prepare for this webinar. It's 7:30 p.m. here in the U.S., so thanks for allowing us to join a bit in the evening on Tuesday. I hope your Wednesday has been awesome and kicked off well. My name is Luke Allen. I'm the president of OHD. Excited to be here today to talk a bit about respirator fit testing and some of the advancements that we put forward and some of those that are coming. So that's a bit about me.
I'm Stephanie Lynch. I'm the Senior Technology and Research Manager, like Peter said, for OHD. I'm actually headed to Australia at the end of next month, so I hope to see some of y'all there in person. Yeah, I'm excited to talk about a lot of the background with respirator fit testing.
And I'm Hunter Strickler, Vice President of Business Development. I have not been to Australia, look forward to going one day, but I'll be discussing some of the latest innovations on the software side that complements our new hardware products that Luke and Steph will be talking about.
Awesome, yeah, well, let me kick us off by just a quick introduction of OHD. We're a US-based company from the southern part of the US. Our corporate headquarters is in Alabama, and we manufacture our products here in the US and distribute those all throughout the US, but globally through great partners like AirMet, and very thankful for our partnership there in Australia. And then we have great partnerships with other organizations like ResFit to advance respirator fit testing. So a bit about OHD and our background. Our main focus is respirator fit testing, as you'll see today on the products that we develop and we sell globally. So we believe ourselves to be experts in that field, both in technologies and application. And we look forward to sharing some of that today. So let's jump in, and Dr. Lynch will take us through some of the basics on fit testing and guide us through.
So I really want to start on a very basic level. So what is a respirator fit test, right? And one thing that we really like to focus on is it's really not just about size and fit. It is about how well you've trained your personnel, how well they know how to don their respirator, how well they know how to maintain the respirator. But that fit test is going to make sure that the respirator that you've selected or that they're trying out is going to provide them with an appropriate amount of protection. So best size, style, model, make, going to get some verification of that training, and you're going to use an approved protocol, which does vary based on the regulation you're following.
That's great.
So why do we fit test, right? Now, all of us, right, we're in safety. We're fit testing because we really do care about the health of our employees. Another one I just mentioned when we talked about what is a fit test, that's to make sure that our employees feel well trained, that they have confidence in the protection that they're being provided, right? And then, unfortunately, the main reason that a lot of people fit test is because we're regulated to do so, right?
Compliance.
We see a 100%, like there's a direct correlation between when it's required and how much fit testing is being performed. So luckily it is required for the safety of our employees by a lot of agencies, right? So here in the US, we're covered by OSHA. It's covered on a more international basis from like ISO, ANSI. The HSE is covering it in the UK, and then of course in Australia, I've got the AS-NZS, so Australia, New Zealand standard, also French. INRS. This is not an exhaustive list, of course.
Sure. And Australia recently, right, has more ISO kind of influence on regulation, or
so Australia is a super interesting case where y'all are the first country to have implemented ISO. And we're actually kind of hoping within my world of respiratory protection with the International Society of Respiratory Protection to see how it goes, right? This is our first use case to get to see how ISO really works when it's applied, because ISO also has a specialized way. It does have a respirator fit testing standard within it, but it also has a way of actually defining respiratory protection. We're really interested to see how that pans out, where you're changing sort of the perspective from performance to, like, from design to performance. It's interesting.
That's great.
Yeah. So who can perform a fit test? This gets very vague, where, especially here in the US, we do not define it well. We just say a qualified person. So is it someone who's competent? Is it that they're qualified? Is it the person who's administering your respiratory protection program? Or is it just anyone, right? You go watch a YouTube video and now you can perform fit testing. Well, luckily, there are some accreditation / qualification schemes out there. One that we are very involved in is ResFit. So that's in Australia, and it's a great program that's happening where you can go in, you're taking a test, it's 5 video, so you get to take an actual written test, and then you get to show yourself actually performing fit tests by whatever method you want to be qualified for, and you're submitting that, and you're having people view it and rate you. Both Luke and I are assessors for ResFit, so we're big proponents of that, and OHD is a sponsor of ResFit. There's also Fit to Fit. That's one that's sort of working its way across Europe at the moment. Some of the European countries are deciding to do their own thing, but Fit to Fit is spreading, and that started in the UK, and we're closely involved with them too. But this is I'm biased. I want people to be well trained to do their fit testing, but this is a better way to have, evenly across the board how people are qualified to do respirator fit testing. So we really do like the accreditation. We have nothing like this in the US, so it's nice to see that it's happening across the world.
Yeah, and one important point from a sales perspective is whatever instrumentation you're purchasing for fit testing or someone you have coming in, ResFit's a great scheme to make sure that the person's competent. But I would say if you're purchasing equipment, the manufacturer and the representative in the country should really also be performing great on-site training, helping you with that. That's something that we really require of distribution partners, because it's really a joint effort to make sure that we're selling equipment that meets regulations, but we're also delivering it with practical how to use it properly, how to troubleshoot issues. That's a big part of fit testing. It's not just passing people, which you mentioned earlier. A lot of people just think, well, how do I pass people? Well, that's really kind of a byproduct of a good respirator, a good training, proper donning, all of those things. So yeah, make sure that however you're getting your training, that it's through a great source.
That's one thing that we actually talk about a lot with our sales force. Like, are the customers that we're dealing with, are they fit testing or are they fit passing?
Fit passing, yeah,
right?
Exactly.
And so that's one thing we use here where we're talking about, we don't even necessarily, not that we won't, but we don't really like to have a customer who's just like, I just want to pass all the time. All I'm looking at is trying to get all my respirators, check the box, right? No, the whole point is to have your employee well trained and for them to be protected. That's the whole purpose of respiratory protection.
That's right.
Okay, so how often are you going to do a repeat test? Well, that's going to be based on your regulation, but some of the general ones you can see are if your wearer has either lost or gained a significant amount of weight. Probably no problem if you see that someone's lost some weight, right? You see someone lose 20 pounds, you're like, hey man, looks like you lost 20 pounds.
That rarely happens, I feel like.
Right, especially at our age, no offense. But so lost weight, fine. You go up and you say, hey, you need a new fit test. No harm, no foul. Now, good luck to you if you want to go up to your employee and tell them they look like they've gained 20 pounds.
Sounds like an HR discussion topic.
HR nightmare, and that's where you really have to rely on having a good relationship with your employees. If they recognize the value of the respirator fit test, truly recognize the value, that it's providing them training, that it's providing them the protection, then they should be the one to come to you and say, hey, I think I've had this substantial change in either my facial structure or my weight, and I would like to go ahead and undergo another fit test.
Yeah.
So some other things, you got dental work. One thing you might want to consider, also maybe based on our age, maybe more for females, I'm not sure, but Botox, even if you're having significant Botox done, that can create changes in your face. Not to say it's a negative God bless Botox, but around the facial area, and then also at whatever your regulated time interval is, which is typically annually, but you can see some variability there.
Awesome.
Okay, so big umbrella style, there are two overarching types of respirator fit testing, and we just really wanted to make it confusing, so we made sure they sounded really similar. So there's qualitative respirator fit testing, and then there's quantitative respirator fit testing. And so qualitative is going to be a subjective test that's going to rely on the wearer to detect that leakage. So your actual respirator user is going to have to be able to detect some sort of test substance. And then it's just a pass-fail test. This is typically limited to half face or half mask respirators. Quantitative is going to use an actual machine to measure leakage, and it's going to provide you with a numerical representation of your fit. So that's your fit factor. And it's going to be able to be used, technology dependent, on any type of tight-fitting respirator. I think we have a few slides we're going to actually work through. Okay, we're jumping right in. So two most common types of quantitative respirator fit testing, and then again, to make it as confusing as possible, CNP and CNC. So CNP is what OHD started with, our flagship product off the bat. We had the Fit Tester 3000, then the Quantifit, now the Quantifit 2. As sort of a bragging thing, we do still have Fit Tester 3000s in service, but maybe we shouldn't brag on it too much. Buy the Quantifit 2. But air is used as our challenge agent. And so we are creating a controlled negative pressure within the face piece by replacing the filters with fit test adapters that are going to sort of block off the respirator so that we can create that controlled negative pressure that's going to replicate an inhale. And we're going to test to measure the exact amount of leakage that goes into the respirator. Then with CNC, that's OHD's AeroFit. We do have some competitors out there that shall not be named, but that uses aerosol as the challenge agent. And so we probe the respirator and we're just counting or counting the concentration of particles inside and outside the respirator and doing the ratio that way. So controlled negative pressure, talked about this pretty good. Your respirator is going to have to be equipped with those fit test adapters. But the idea is that once you have created that controlled negative pressure within the respirator, then any air that you're having to remove to maintain that pressure is a leak, right? So the ratio of that leak rate to the total air inhaled, which is that pressure rate, then that's our fit factor for controlled negative pressure.
Yeah, and one key point on CNP that I think is a bit of a kind of a misunderstanding is that the unit pulls, or the system pulls, a consistent breathing rate for each step for each person every time. So you get a consistent breathing rate that's able to be defined, and then you're able to set, which is important because a lot of times in fit testing, you can see variability around like deep breathing steps or movement steps. And it's important that you're really doing each exercise the exact way that it was supposed to be performed. And one of the things that CNP does is it sets a breathing rate where for each person, every single time it pulls that high challenge rate, which we've seen to be very effective throughout fit testing on that, and specific to CNP.
That's actually a really good point. And so this is something that I've realized I haven't done a great job of communicating all the time, which is that there's the big fundamental difference between CNP and CNC is that with CNP, the instrument is creating the challenge, right? And with CNC, the user, the wearer, is creating that challenge. So that's a real fundamental difference between the two technologies. So yeah, okay. So just how it works, and maybe we've already kind of done this to death, but one tube is going to be pulling that negative pressure. And essentially to keep that pressure constant, it's going to be evacuating any air that's leaking into the respirator. So that's why we say it's a direct measure of leak. And we convert that, so it's try to think of the total air being inhaled being compared to that leak rate that's being measured. So that's how we do with CNP the fit factor, which is very different from CNC, and we'll talk about that. So the benefits of CMP are that it has absolutely no environmental requirements. If you have air, you can test there. So that's inside, that's outside, that's dirty, that's clean. It is highly portable. It's got that battery, and because it doesn't have those environmental requirements, you can literally take it anywhere, take it out to a construction site, you know, do whatever. Our single greatest limitation with CMP is that it cannot test the filtering facepiece respirators, or N95s, you might have heard them called. So that's what we essentially went and set out to address, right?
Yeah.
So with CNC, this is actually going to use laser technology to measure concentrations of particles both inside and outside of the respirator. You have to have your respirator equipped with the appropriate filters, and the idea is that if you have a good enough filter, that any particles that you're counting inside the respirator are coming from a leak source. So the ratio then of the concentration inside and outside the mask is how you're comparing to get that fit factor. So this is a graphic for the CNC. As air is being sampled through the ambient side, you know, that you've got like a lever that's kind of switching between the two. So you're going to test that ambient environment, get a concentration of particles in the ambient air, and then you're going to test within the mask. And that's happening for either, you know, the beginning of the test and then through some exercises and at the end of the test, or for some protocols, it's testing before and after each step. So once it comes through, it's going through some isopropyl alcohol that's going to very magically really grow that particle to where it can then be counted by the laser. So as you see that particulate, it would pass through the laser and it's going to get counted. So that's how CNC works. So just real quick explanation of how then we wanted to use CNC to test N95s or filtering facepiece respirators. A little bit of an explanation just because here in the US and possibly in Australia, you're hearing that phrase N95, right? And that's actually kind of a misnomer. I don't know the right word to say it, but that's really the very lowest level of filtering facepiece respirator that can be approved. So that N series, it being designated as N, means that it has no resistance to oil. And then that 95 is 95% filter efficiency. There are actually 9 levels at least approved by NIOSH here that you can see. So one kind of interesting thing is during the pandemic, for instance, when N95 respirators went into shortage, I actually could still find P100 and R100. Okay, so talking about CNC, when you originally had CNC, it wasn't specially designed to test these filtering facepiece respirators. So when you talk about that lower filter efficiency of 95%, you had to find something new to do. So they implemented the use of a differential mobility analyzer, which is going to look at particulates of a particular size that are outside of the most penetrating particle size for these respirators. So that then you could say, we're not counting that 5% of particles that are most likely to be leaking in. We're actually looking at a point where the filter is very efficient and these particles can be assumed to be leakage, right? Be part of leakage. So that was the purpose of this slide. So the benefits of CNC are, of course, that it can test then any tight fitting respirator. You know, we wanted to have this technology so that we had an option for testing filtering facepiece respirators, but it can be used on anything. Some of the limitations are that it does have environmental requirements. You have to have enough particulates in a stable enough atmosphere inside your air. It is going to use some consumables. So there's that isopropyl alcohol. There's the wicks that you're having to absorb that alcohol on. I don't know if I can't remember if I'm forgetting something. You know, you're probably gonna have some particle generation, so some salt, tablets, stuff like that. Another limitation is that the test subject is not gonna be able to eat or smoke for about 30 minutes before testing. Also things like chewing gum can interfere. So anything that might have the subject producing more particles than normal.
Right.
One confusing aspect of respirator fit testing is that I just told you that there are very different ways for both CNP and CNC to calculate their individual exercise fit factors. So that was where CNP is using the leak rate and the total air inhaled, which is that set breathing rate. And then CNC is using the concentration of particles inside and outside the respirator to calculate a fit factor. Well, once both of those technologies are done calculating their fit factors in their very different ways for those individual exercises, they both use what's called a harmonic mean to calculate the overall fit factor. And the whole purpose of this is to just place greater weight on the lower values, to be more conservative. So this is that harmonic mean and how we calculate either technology, the overall fit factor.
Awesome. Yeah, and those are some things that are confusing to a lot of people on how fit factors relate, and there's probably more information that we could give on that at a later time.
Oh, 100%. We could have done a whole...
Yeah, and we have to have a white paper on that as well. Great, well, that's kind of a background and painting with a broad brush and giving some detail on fit testing. Let's now move into some of our latest advancements in respirator fit testing. And one thing that you're probably aware of with OHD, and Stephanie, Dr. Lynch already mentioned that historically CNP and Quantitative 2 has been what we manufactured and sold globally. But recently we've announced the AeroFit system. Just quickly from a high level, we've already mentioned that this can test your disposable FFR N95 respirators and up, so all elastomeric respirators as well. Some new things that we've really brought into the CNC testing is a very simple configuration. If you've used the Quantitative 2 system before, the user database is in the instrument. We store all records in the instrument as well as through software if you run it that way, so multiple ways to operate the system. There's a full respirator listing on the unit with images of the respirator that's tied back to standards that make just setup very, very easy. That's all through your interactive built-in screen. So all of that is in both systems, Quantitative 2 and AeroFit. And then some rapid and efficient testing advancements that we are putting together and announcing. All of those will be new with the AeroFit system that's continuing to be on pace to finalize and launch by the end of the year. So one thing that we'll announce today, it's a really cool advancement. It's kind of a low-level thought, but it's something that is we think is a great advancement in the space, is kind of a built-in zero port. So if you're familiar with CNC technology, you have to keep a HEPA filter outside of the instrument. You have to keep up with it. You have to kind of use that for a zero check every day. And what we've done is engineered that into the instrument. So it removes the concern of losing the HEPA filter or breaking it or wondering if it's still good, whatever. Those can be changed out at annual service very easily. So as you can see on the front of the instrument, for the zero check, instead of using an external HEPA, which you still could in theory if you would like, you would just plug up to your zero port check there on the front of the instrument and be able to do a zero check straight with the instrument without any additional pieces. The other thing that you're seeing on the far left of your screen is an example of one of the guidances that we put in on the screen of the instrument to guide the user through actions like a daily verification. Some people call that a daily calibration. That user interface and user experience is a great addition to fit testing. So it makes the calibration or setup each day much easier and easier to guide through. So excited to make that announcement today, and more to come on other announcements and advancements that we put forward on CNC fit testing. Another thing, we've talked a lot about CNC and AeroFit, but jumping back to Quantitative 2, this is an advancement that most people are still unaware of, and that is our integrated valve prop adapters. These adapters remove the requirement to prop open or remove inhalation valves for CNP testing. That was one of the most kind of cumbersome pieces of a CNP fit test. You had to remember to do it. We had a lot of great user experience instructions on our unit to help guide through there. But with these adapters, it automatically props open as you see in the picture, and then those props will stay with the adapter when you're done with fit testing. So it allows you to very easily and softly open up the valve, do a fit test with CNP, remove the adapter, and go right back. So it increases convenience, speed and efficiency, and consistency across your fit testing. So these adapters really are almost across all of our range now and widely available if you're currently using a CNP instrument for testing. One other advancement that is important for us to announce and make sure there's clarity here is that both of these technologies and systems can operate in standalone mode with virtually unlimited data storage, or they can operate through a software system. We get that question all the time. There's other machines on the market that maybe don't have as much onboard data storage, or they have requirements for a tablet or other things to operate the machine. Both the AeroFit and QuantiFit 2 have virtually unlimited data storage on board, report capability, you can print straight off the instrument. It also has signature capture on the screen, so the reports are saved in PDFs with signatures after a passed fit test. All within the instrument, or you can run the system through software, like anybody's used to historically. The OHE Logic software can also operate both of the systems simultaneously. This is a really cool thing for fit test operators that are running multiple machines or that are running multiple technologies, which is something that we're really wanting to highlight today. If you're a tester and you're going out into the market, you can operate a CNP machine at the same time as a CNC machine through one computer, one software, designate employees or test subjects at different units for different test applications. That's never been done before. It's currently not available in the market. OHE will be the first company in the world to have both technologies, being able to run both of those simultaneously. So a super cool option if it's something of interest to the application. And that's kind of shown here. So one software, two instruments. So through the database, you can do reporting, you can do sorting of data, you can operate the machines individually or at the exact same time, no matter the number of units, run a couple of systems with two different technologies as we talked about. So really cool advancement here for AeroFit. And that really bleeds into kind of our advancement on our cloud software. Hunter, if you want to take us into that chapter.
Absolutely. So a couple of different versions of the software. So Luke mentioned that the Logic PC downloadable software can connect and power both instruments. One of the things that we really set out to do this year is to actually investigate and ultimately launch the first of its kind in the respirator fit testing market, a cloud-based software to help users and organizations track compliance with applicable fit testing regulations. And so we introduced this sort of second version, or this premium version of the Logic software that we're calling Logic Cloud. Now, keep in mind that this was developed primarily, or at least initially, when we launched it for a US market, and there are a number of requirements in the Australian market with respect to data privacy and certain restrictions that we have to comply with to make it compatible for the Australian market, but we're really not far off. In fact, the fundamental technology was built with things like that in mind, and so in fairly short order, we'll have the ability to sort of introduce this into the Australian market. But this was developed really in close proximity to a number of large customers of ours, really here in the US, but around the world. And the foundational thing that we wanted to deliver is the ability to process data from multiple databases, from multiple locations, from multiple respirator fit testing devices, and different types of devices. So both the QuantiFit 2 and the AeroFit can connect the databases through the cloud to this web-based software where you would have a user ID and password, you would log in and have effectively an at-a-glance view of what needs your attention. So if we go to the next slide, we'll see just a couple of concepts here. So again, both of these, just like the Logic PC software can connect to each instrument, you can also connect the databases from either device or either instrument to the cloud. And so a couple of the screenshots on the following slides will sort of show that this is designed to say what needs my attention, who's past due, who is coming due soon, as defined as due in the next 30 days, who's already in compliance, when is my calibration on my instruments due, and then further on the next slides, you can drill down, filter those lists, you can see individual test subjects, you can drill down to their individual fit test results, you can of course download or print those results. There's a number of ways that you can slice and dice the data, including building a hierarchy if you have sort of a multi-site, multi-location, multi-region, or multi-department way that you'd like to drill down into that data, into those data sets. So the system is very flexible in terms of how you can query the database and how you can collect information on fit testing subjects and their respective due dates and their respective compliance statuses across all of your fit test subjects and locations.
Yeah, and one thing, Hunter, too, which we see a lot in the Australian market, is there's a lot of fit testing companies that are going out and doing service. And one cool thing about this is you're able to push data from the cloud to an instrument in the future to, load records or pull data. And again, that's something that's never been done. And the kind of unlock the portability of some of these units or being able to move around to different sites. It's just the cloud unlocks a lot of that capability and reporting, so super cool.
Yeah, and one of the other nice features that our clients are appreciating about cloud on the next slide is that you can actually set up rules to automate email reminders either to your supervisors and managers to say, hey, show me a monthly report of everyone past due at these locations. You can set it and forget it. It delivers to your inbox according to the frequency and the time that you select a past due list of everyone at that particular organization or location. You can also do this to your individual fit test subjects where applicable, where you can say, listen, if someone is coming due in 30 days, I'd like them to get a weekly reminder that just says, hey, your required fit testing is coming due. They get that delivered to their inbox. And then maybe we set a rule that says, look, if they're past due, we want them to be notified more frequently because it's a bit more urgent. We'd like them to actually clear that up, and we may ping them every day. And so the point of the notification system in the Logic Cloud software is that you can really automate those types of reminders, both at a summary level, but also at the individual level where appropriate. The other innovation that we have set out to deliver to the market this year is what we're calling OHD Academy, which is an online training center that really houses the how-to guides for how to use our instruments. So we have a course, for example, on how to use the Quantitative Fit 2. We're in development of a course on how to use the AeroFit. We even have courses on how to utilize our software, the companion software for each instrument. And so while these are not really designed yet to be necessarily ResFit accredited courses, these are a bit more abbreviated how-to guides, but they're really sort of delivering some specific value to a brand new operator on how to use the instrument, what needs your attention, and it's really sort of a brass tacks way of delivering this content in an online way that makes it very flexible. And this is just one example. There's interactivity built in, there's quizzes, there are, it's a video-based training. There's a certificate that automatically is delivered to the end user upon successful completion. Again, a bit more abbreviated, so these are not lengthy courses. They're not necessarily built for, academic purposes or any of those things, but they're short and sweet courses on how to use the instruments, and they do measure proficiency of the learner through a series of interactive quizzes. So we've had a number of really good reviews thus far on our how to use the Quantitative Fit 2 course. It is designed for individuals to sit down at their own laptop or computer and take the course and again get their certificate upon completion. And it's just another way for us to deliver knowledge from our team to fit test operators around the world.
Yeah, that's great. So those are some of the advancements, and I think now we wanted to spend just a second on really talking a bit about what is this a new concept for having multiple technologies.
Yeah, so like some scenarios to kind of walk through of, which instrument is going to be right for you, or how we sort of see it playing out. So, thinking about if you're in healthcare, for instance, and you're doing majority, if not all, filtering face piece respirators N95s, but you're doing an abundance of them, right? So qualitative is out of the question, or it should be. At this point, if you're working with that many people. So, which instrument is going to be the right fit for you?
Right.
AeroFit, right?
Yeah, in that scenario.
In that scenario, it's going to be AeroFit. Well, say it's more nuanced and you actually have some elastomerics that you're working with, and you have some filtering face piece that you're working with because you're doing fire and EMS, right? Like maybe you're have your SCBA for fire response, but you have some EMS personnel who are working with just the filtering face piece respirators, thinking about maybe a COVID scenario, right? So maybe which instrument is right for you? Well, if you're doing enough fit testing, maybe that answer is actually that it's both, right? Yeah. And we really want to make sure that we are doing the best to make that a reality, like a feasible response for our customers. And that's why we put so much effort into making it where you can use both instruments. Well, say that you work in oil and gas, a refinery, something, and you're only using elastomerics, and also you're out at maybe some rougher sites, thinking about what you're dealing with, and you don't want to pull all of your workforce out to some central area. Well, what's your best case then? Quantitative 2. And we still just we want to give our customers the best experience with working with us. We want to be able to tell them, how we can best help them with their fit testing needs. So we want to remain true to some of our values about just helping people, protecting people the best we believe. So, there are instances where we say if you're only working with elastomerics, CNP is going to be your best way to test. But when you're not, that doesn't mean that anything's bad about CNC. It's a new opportunity for us. It's a new opportunity for our customers, and we want to be true to that, right?
That's right. Yeah, which really, Hunter, leads us into this concept of breathe easy, which Stephanie just laid it out very well. Having both technologies at OHD, we really look at kind of an assessment of what's the best application for the user, right? What's the best technology?
Yeah, in an unbiased way, right? So the whole concept around us being around OHD being the first manufacturer to offer both the CNC and CNP technologies is to assess the practical application of your fit testing program and be able to recommend confidently the right technology to meet that application. And so, there's, I think, a good bit of benefit for us and for the market to be able to say, hey, we're going to offer both. And, we'll be able to talk through each individual scenario, and similar to the ones that Steph just mentioned, we'll be able to say, hey, our recommendation is for you to use this particular product, Quantitative 2, or you could use the AeroFit. This is really your only option if you're in the sort of disposable respirator only testing. Or in some cases, it's either or, and we'll be able to describe the pros and cons of each and allow you to sort of choose the right one for you.
Yeah, and ultimately support both. Yeah. Right. So that's another benefit, is being able to support both technologies within training and instrumentation. So that's our concept of breathe easy. Pete, I think we're to some time left. I think we have time left for some Q&As potentially. Hopefully this has been
thanks, Luke. We do. We've already had a few questions come in, which I'll start with. But if anyone else has questions, just type them into the questions box or the chat box, and we'll get to them. So the first one it says, surely a person's breathing rate changes over time and activity during the CNP test.
Sure. Well, yeah, during the test, I guess the question would be, are you challenging the respirator with the appropriate breathing rate? And the way that we do that is we pull a very high breathing rate, 53 liters per minute, 93 liters per minute. Some of our users are using 93 liters per minute. And so to challenge a respirator at 93 liters per minute with a human doing that is basically you can't do that in a fit testing scenario. To breathe 93 liters per minute for 60 seconds, for example, would be very, very strenuous. Now, in a workplace, you could have scenarios where that person is breathing in a respirator at a very high rate. So in a fit testing scenario, from a CNP perspective, you would want to pull a breathing rate that's reflective of that work rate, and potentially at a higher rate, like if you're a first responder or military, for example. You want to simulate something that would be what you would challenge that respirator in. It's hard to do that in a qualitative fit test or with CNC in a way, because you're forcing the user to breathe at those high extremes. For example, like a deep breathing step, most people are not breathing deeply at the levels they would if they're fighting a fire or first responder to a bomb threat or something like that. So That's an important thing to understand, that when CMP pulls a breathing rate, it's not fakely assuming that it knows what people breathe at. It's using a scientifically based breathing rate at a very high level to challenge the respirator higher than what the person could do through those steps. So that's an important thing to understand when you're thinking about CMP.
It really goes back to what I mentioned, that I feel like maybe I haven't done the best job of describing in a lot of my talks, is that the fundamental difference between the two technologies is that with CMP, the machine is creating that challenge. That's what it's designed to do, and that's based on scientific research. And then with CNC, not to be any sort of less so, it's using the user to create that challenge, and it's been scientifically validated to do so with how it does it. So it's just very different.
Yeah, for example, in the CNC test, really there's no part of a fit test that says, do deep breathing like you do in your workplace. It just says, do deep breathing for a period of time. Well, what type of deep breathing? Is it deep breathing like I do here, or is it deep breathing like I do in the workplace? So that would be something from a CNC perspective or qualitative. When you're doing deep breathing, really the question should be, are you doing it deeply like you would in a first responder scenario?
Right, is it reflective?
Is it reflective of that? With CMP, we set that breathing rate, so it does reflect whatever we set during the test. So just a different way of looking at it, and something to keep in mind.
Yeah, thanks. The next one is, and Hunter may have answered this already, but can you have a cloud-based database so that multiple units can upload and be linked with fit test records and RPE lists, i.e. one operator can enter a 3M6000 mask and another operator can see that change in their software?
Yes, you can. So yes, multiple devices, multiple respirators, multiple administrators on the part of the organization, so that and different permission levels for each administrator, such that you can assign administrators to certain regions, divisions, locations, upload data from multiple devices, and then be able to set the controls over who can move people around the organization, who can view certain regions or subsets of the data. Yeah, I think hopefully we answered that one.
Thanks, Hunter. Here's one from Mark Reggers. Will AirMed have an AeroFit at the AIOH conference? Yes.
Yes, yeah, there'll be an AeroFit there. Dr. Lynch will have a system with her and be able to show through some of the features and maybe announce some new.
Come see me, Mark.
Some new things, yeah. We're announcing some new features slowly over the next number of weeks and through the end of the year. But yeah, the plan is to have a system there in Perth, I
yes.
believe.
As you well know, Mark, catch me before 5.
Yeah, exactly.
And question, what are the consumables? Wicks, alcohol, etc.?
That's right. Yep. So the AeroFit system, I'm assuming that means is going towards the AeroFit, right? AeroFit system is using consumables. It was the same as any other CNC technology. So isopropyl alcohol, wicks, things like that. We do have some advancements in the unit that will help with some of that consumption. So more to come on that, but same consumables.
Well, minus the HEPA filter.
Minus the HEPA filter. Yeah, you don't have to keep up with the HEPA filter unless you like to. Some people might enjoy it.
If you like it.
Yeah.
Okay, and the next one, how long is the setup for the AeroFit and roughly how long does it take to conduct a fit test with AeroFit?
Great question. Yeah, you want to take that?
So there are fast fit protocols for CNC technology that are also going to be able to be used with the AeroFit. Now, I do not think that as of yet those are definitely not ISO accepted. So I imagine that they're not in the Australian standard yet, but I do know they're being considered. They're approved here in America, and they are, as far as I'm aware, they're being pretty much considered all over. So test time would be 2 minutes and 29 seconds exactly. Setup time is very comparable to CMP. Well, a minute or two. Like it's.
Yeah, well, I think setup time, it depends on if you're talking about getting the environment correct and things like that. So with CNC, really there's a daily verification that's conducted, and that's a couple of minutes, whatever, to do the actual verification. but you do have to get your environment correct. You've got to get the right particle concentration in the room for testing, whatever. So with CNC technology or AeroFit, it's going to be very comparable to other CNC instruments from a setup perspective and what's required. And then again, with CNP, it's a minute or so daily verification, and that's it. You don't have any environmental concerns or questions, and even power. Both of the systems can run without power, so there's less setup kind of planning or requirements there. But that's just a quick overview. And then from a protocol standpoint, the testing time is driven not by the instrument, it's driven by the protocol. So, we don't have a faster testing time with our CNC instrument because it's specified by regulation, the steps, those type of durations.
Yeah, you drive everything by your selection of both your regulation and then your selection of your respirator that you're testing. And the machine then knows which one to do for both instruments.
That's right.
Great. Is there any development to allow Mac computers for the software?
Yeah, the software is really web-based, so or the Logic Cloud software is web-based. The Logic PC software can be downloaded. It's a free software. It is Windows specific, so not to my knowledge on the Mac side, but it can be downloaded on a Windows device.
Thanks. What's the anticipated launch date for the CNC machine?
Ooh. Before the end of the year.
Yeah, so still Q4 is still the plan. So before the end of the year, so at Perth, we should have a system there that's final or almost final. So what we're waiting on right now is a few certifications. We're waiting on a few feedback pieces. We've done a great job of taking in beta testing feedback, things like that. So yeah, excited about finishing that out before the end of the year. And having a great product that can connect across the softwares and everything else that we're confirming right now.
Thank you. Okay, the next one. Are there any laws or regulations in Australia that determine who is competent to fit test? Are people allowed to fit test without doing any courses?
You definitely wouldn't be obligated to do a course, but ISO does have. Here's kind of a tricky thing about what ISO requires. It's walking a pretty fine line because it does ask that the person have certain competencies that I would contend get to the level of if you were able to recognize all of those competencies in another person, you're probably capable of doing the fit testing yourself, which is not typically how it's going to work. So my recommendation would be that if you're in Australia, go through ResFit and then you are assured to be meeting that standard. So that would be our recommendation.
Yeah, and really Mark probably could answer that as far as the regulation, what it specifically requires. But I think the main message would be if you're conducting fit testing, you need to feel confident that you've been trained adequately and that you understand how the technology works, how to troubleshoot failures, how to look for false kind of readings from too high a particle concentration. What does that mean? Why would that impact the fit test? So because if something goes wrong, you or the tester are going to have to kind of answer on how did you know that you were doing it correctly. And so I think there's a number of ways to do that well, but as long as you're not cowboying it up or something like that, as we'd say in the US, right? You pull the machine out and just go fit test. But ResFit does that at the highest level. And that allows you to have that certification from a third-party group that's gone through qualification, and boom, you've got it. So
yeah, if you're concerned about your competency, then
that's
what Mark's added into the notes here. Comes down to a demonstration of competence. So Mark's yep, good. Does the AeroFit require a separate particle generator?
It doesn't require one. It would require a particle generator if the environment needs more particles generated, which a lot of times they do, especially if you're in a highly efficient room or area or whatever. It does not have a particle generator in it. If that's part of the question of like, does it require one outside of it? There is not one in the machine, but it will be able to use a particle generator in the same way to create environments for the right particle concentration for testing.
Thanks. can AirMet calibrate the AeroFit in Australia? Well, I can answer that one. It's our intention to set up to be able to calibrate the AeroFit here in Australia, and we are set up to calibrate the Quantitative here in Australia, so we can do that. Got another one here from, sometimes our machine passes the fit even though the machine has suspiciously high levels. Should I trust these results? Tony.
That's a great question, and one that there's a lot of documentation on. Stuff, I don't want to steal the mic right there, but yes, if you have suspiciously high particle concentrations or counts, and you're passing people, and there's, especially if the machine is telling you there's high particle concentrations, then yes, it's clear that there could be something to be concerned with. Really, that's why you don't want to have particle concentrations that are crazy, crazy, crazy high. You also can't do testing, obviously, if they're too low. And most CNC machines have some guardrails there, instructions in the user manual, things like that, that give you troubleshooting examples there. But yeah, I mean, without seeing the reports or seeing the fit test, it's hard to say yes or no to that. But if you're seeing suspiciously high particle concentrations and it's making you question the fit test results, then the prudent thing to do would be to use that data and redo those tests or do them in a different way when the concentrations are more adequate for testing, right?
Absolutely. I mean, it becomes exponential when you look at how fit factors are calculated. So you do want to, yeah.
Yeah.
Thanks. Another one. Do you have any stats on the preference of CNP over CNC in the US?
Yeah, it's a great question. I think part of it too is that, you know, technologies are kind of address different use case scenarios, which gets back to our breathe easy concept of, you know, users can choose technologies based on preference, but they also can choose technologies based on practice or application. And so, you know, from a hospital healthcare standpoint, it's 100% CNC or qualitative, right? If you get into fire or first responders, in the U.S. market, the top 10 largest fire departments in the U.S. use CNP technology. And so if you were to kind of look at that from a grand scheme, it just depends on the kind of application of what it is that they're testing. So it's hard to say. It depends on the market, and it depends on, again, the respirator application or mix thereof, and that would be kind of the best way to look at it.
Thanks, Luke. And the last one, I think for CNC, are there any room size requirements to perform the fit test?
So there's guidance from some of the CNC manufacturers, legacy manufacturers, that give recommendations for room size, but part of that's based on kind of generating the right, you know, particle concentration. So I think it's hard to say there's a right room size, because that really depends on, like in the room we're in, we have one kind of, you know, air receiver or kind of balancer. So if you get into other areas where you have zero or you have multiple, then that could change the room size requirements. It's funny, I've seen CNC fit testing in a closet, which was kind of weird, very tight. And then I've seen CNC fit testing in a bigger room where there's you know, ability to create and maintain the right particle concentration, right?
I mean, it's very room dependent, because you look at our HVAC systems and they're going to rely on turbulence, right? The whole point is to mix up the air to get everything to even out. And that isn't great for CNC fit testing, because you want some stabilization of your particle count, and you're hoping that those particle counts are going to be reflective of what's happening throughout the whole room, not just where the instrument's counting. Mm-hmm. So, you know, a lot of times when I was doing CNC testing, I was doing things like covering up the exhausts and making sure that my room was able to be more stabilized, and that was easier for me to do in a smaller room. But yeah, it's room dependent, it's very situational dependent. You need to, the more testing you do, the easier it is to identify what's appropriate for your testing environment.
Great, thanks very much. Yeah, that looks, Mark's added in Mark Riggers has added in, room size consideration is about getting a stable ambient particle level, so smaller is generally easier to achieve this.
Yeah, for sure. Yeah, and that's just yeah, common sense, right? The smaller the room, the easier it is to create a concentration that's somewhat stable. Yeah, but I think it's important just to, again, be trained on what is the kind of optimal range. What are you trying to do? How do you keep it stable? And and the right generation. It's another thing that's important. I haven't heard a question on this, but we've seen some weird practices on generation of particles, and some of it is questionable at best. Heavy candles where they're sitting right beside the machine, or other things where they've got particle generators that are sitting right beside the instrument, pouring kind of salt fog into the. There's a lot of stuff that you just need to be sure that you're creating the right concentration in the room the right way, so that your fit testing is being conducted properly. And that does take training and takes time of understanding the technology.
Thanks. Well, that looks to wrap up all the questions. So thanks everyone for joining us today. I'm sure you found the session both informative and engaging. And as the exclusive distributor of OHD products in Australia, AirMet's here to assist with any inquiries regarding the OHD Quantitative Fit 2 or AeroFit. Steph's already mentioned, but for those of you who are attending the AIOH conference in Perth, Stephanie will be there, so don't miss out on the chance to meet her and see a live demonstration of this cutting-edge technology. And finally, thank you so much to Stephanie, Luke and Hunter for accommodating our time difference and delivering such an insightful presentation on effective solutions for respirator fit testing. So thanks very much, everyone.
Thank you.
Thank you.